Dear students, hope you are safe and good. So by continuously today I am going to take a chemistry class about periodic table. Also previously I have taken 2 classes in this channel. I hope you have enjoyed it and also you have understood everything I said, and also we have a good response from those classes and in this comment and also in the Facebook page. So I am gladly appreciated your support. So now this is a chemistry class about periodic table. So let's move on. We already knew that all the elements in periodic table arranged serially according to their atomic numbers, right? I think you also know that, and also my previous classes I have told you a lot actually. So their atomic numbers, so they are in group 18 and 18 groups and 7 periods. Also we know that in the periodic table the elements are arranged in such a way that the elements get categorized according to their properties, right? So we know that in periodic table the first group except hydrogen consists of strong alkali metals. The second one is consists of alkaline earth metals. The right of the periodic table consists of the non-metallic elements, also including the noble gas and metalloids. Group number 17 is called halogen family. Those elements are called halogens, right? Like chlorine, fluorine, bromine, iodine, astatine, all those things. Also, noble gases are in the 18th group. In the old or ancient periodic table, we can say group number 0. So I think all of those are old moves of us or old speaks to us. So let's discuss about the main topic of our today's video, that the finding position of any elements in periodic table. For this you should know the atomic number of that element. Okay, so just if you know the atomic number, then you can find the position. Okay, so if you want to know the position, then you have to know the atomic numbers minimum. Okay, but in a complex way, in a bit complex way, we will get through the orbital systems. But first of all, we need to know the atomic number of the elements, given elements in this periodic table. Then we can find out the position of the given elements in periodic table. So the period of element relates. So first of all, I am saying you this: the period you can find it is in a normal way, or you can say the same way. Okay, so I am going to discuss about the way to finding not just position, actually the group. Actually the group is a bit complex way. So for finding the group there is a complexion about the normal ways and the typical normal typical ways, and also the complex ways finding not just the atomic number or not just calculating atomic number, also we have to calculate the orbital system. Okay, we will go through that after we get past the normal way. So normally the period of element relates the number of shells of an atom of the given element. Think about that, what I have said. The period of element relates the number. Now I am writing it in a board. I think you should write it on your notebook too. Actually there is 2 rules. So number 1 is the period of element relates the number of shells of an atom and number 2 are So these are the normally through ways. I think you know what is the shells and what is the valence electrons, right? So I'm discussing in a short way about shells and valence electrons. So shells, you know, the orbits, right? And also in a modern way we can say it outermost energy level. Actually energy level, outermost is the last shell or last orbit. Suppose the sodium has three orbits or three shells. So the outermost one, the last one. So like the first shell has 2 electrons, second shell has 8 electrons, and third shell has 1 electron, right? So the third shell has every shells or every orbit are called in a particular energy level. So first energy level, second energy level, third energy level. There is also if the period is dependent on it, then the periodic table has 7 periods. So but the highest or the best, or you can say the last shell, the highest number of last shells will be 7, right? So we haven't discovered any element that can goes beyond the 7 period or 7th shell. So between 7th shell every element can goes through. So this is the normal way, and for the group actually the period is in the last shell or last orbit or energy level, whatever you can say. It is the main theme of finding period, but the group is another thing. The group is a bit complex way, not just you can calculate the atomic number and you can find the group. It won't possible. So you have to get through a just not the normal number. You have to get through the orbital, or you have to get through the valence electrons, and also the valence electrons. What is the valence electrons? I think you know that the second or third chapter has a discussion about valence electrons. Those valence electrons are the number of electrons that can use to react, right? That can use to react. So we know that the water can be made by actually hydrogen and oxygen, right? Made by hydrogen and oxygen, but in this system, hydrogen the number of hydrogen elements are 2 and the number of oxygen elements are 1. Why? Because the difference between them in valence electrons. Suppose oxygen is sharing or giving, whatever you can say, he can share or he can give 2 electrons, but one hydrogen can only take or give 1 electrons. So think about that. The hydrogen is giving or taking 1 electrons. So everything he has this 1 electrons, this single electrons. So this is his valence electrons. He is using his single electrons to react with any other element and making other stuffs. But in the same case, oxygen is actually giving 2 electrons. So the valence electrons of oxygen is 2. So that is the short way to tell you what is the valence electron is. So this is the normal way you can find the group. But in a bit complex way, I told you earlier that in a bit complex way there we can find because somehow we cannot just measure valence electrons. Suppose in a lead or in a plutonium, those elements has too much electrons to actually calculate every time, that you can just cannot calculate every time in the perfect way their valence electrons. So we have to get another way. Actually another way, that means an easy options, and actually of course not made by me. Of course it is an easy sections or easy way I can find this. So we'll go through this systems. So first of all, before we go through the systems, we can actually make some examples of those of those rules. Suppose the period of element relates the number of shells of an atom. Also I've already told you that make the examples of sodium. Like sodium is what we can say. Sodium is first shell has 2 electrons, second shell has 8 electrons, right? 1, 2, 3, 4, 5, 6, 7, 8, and the third one is has 8 first a single electrons. So this is the not the matter that what number of electrons they have, but the matter is how much shell they have, right? So think about that. There is a first shell, second shell, and third shell. So sodium has 3 shell, right? Sodium has 3 shell. So 3 will be his periodic number. 3, okay? He is in the third period. Think about that. That how much electrons he has, this is not the important fact to finding the position, but for actually to find the group period, but for finding the period, how much shell he have, this is the important thing. How much shell he has, this will be the number of his period in periodic table. So he has 3 shells or 3 orbit or 3 energy level. So his periodic his period number will be 3 in the periodic table. As in the same rule in a potassium, just think about that. In a potassium, the first shell has 2, the second shell has 8, the third shell has also 8, and the fourth shell has 2. So it has 1, 2, 3, 4. So it has 4th shell. Think about it. It has 4th shell. So it has 4 shell. So the shell number, highest shell number is the 4th shell number. So the period of potassium will be 4. It has 3 shell. The period of sodium is 3, and the potassium has 4 shell. So the period of potassium will be 4. So these rules will be same for every way, not just every way. The bit complex way, the finding the group, but the finding the period is okay. These rules will be okay, or in a typical way. It's the most used rules to finding the period in periodic table. So I'm not go through those complex way to find the periodic table. Like in your level, of course, the teachers or the SSC exams committee not giving you a atomic number of 92, and he won't tell that to find the group, find the position of an element that has atomic number of 92. But I think you can find these systems, and you can follow these rules, and you can also find the position of periodic table. Even it has the atomic number of 92, it doesn't matter. If you can follow those 2 simple rules, you can find the position of the given event in periodic table actually. So in a bit complex way, there is another system. So I'm go through it. I think you have understood these sections. So let's move on. Of course, after following or after writing every rules, I'm going to make you examples that you can understand to find the positions in periodic table of any element. So I think go to the next level. So I'm telling you this one. The period of the element relates the number of shells, or you can say shells, orbits, or energy level, whatever you can say. Shells, orbits, and energy level, the same thing. Don't be confused about those things. That shells, orbits, or energy level are the same thing. Shells have electrons, also orbit has electrons, and also energy level has the electrons. Those cyclic around those circles are orbits. Okay. And the most probable place that has electrons are the orbitals. I think there is a concept about orbital orbitals in the 2nd and 3rd chapter. And also I think we have completed it, and you have the enough knowledge to go through it. If you haven't enough knowledge, then please leave me a comment. Okay. Also inform me in the page, then I will try to go to make another video or another lecture about orbit and orbital, and the difference between orbit and orbital, whatever you can say. So let's go through the another ways that we can find the position of any elements in periodic table. Also I think there is a limitation of these rules. There is a limitation is the transition metals and the non-transition metal, right? For transition and non-transition metal also, just think about it. Just open the periodic table, and also just in a middle. Okay, so I think the periodic table is like that, right? Like here is a hydrogen, here is also a calcium. Okay, is it? No, I think there is a beryllium or what? Yes, it is beryllium maybe. So they are like this. Okay, so in this section, think about that. In the middle there is some metal you can find. Those are called transition metals or non-transition metals. So those are divided into two parts, the transition and non-transition. And also the non-transitions are in actinium and actinide series and lanthanide series. Those actinide series and lanthanide series is also the transitional metal. In this group and the actinides and lanthanides, those cannot be calculated by these rules. Period, it will work, but for the group it won't work. Okay, because they have the similar way to react with one another and making other compound by them. So the combination of the electrons are a bit not in a regular way, in a bit complex way. I will discuss it in another video. So I'll go through the next systems or the way we can find. So the new systems I've told you about, I've just told you about the new system. For these new systems, if we know the atomic number, this won't be enough. We have to know the orbital number and the electron number of each orbitals, right? So now I am making through the rules 1 and 2 and 3. There's actually 3 typical rules to find position of any elements. Actually, to find the not finding the position, we know how to find group. To finding the we know how to find the periods. To finding the group, there is a complex ways we have. So now I am discussing about the complex ways, not the typical ways, because every time you won't calculate the valence electrons, but every time you can calculate the SPDF, those orbital consist electrons numbers, right? So the first rule is just what I am saying. The first one is, if the outermost energy level, or we can say orbit or energy level, whatever you can say, so I'm writing it. I think you have to write it because there is a lot to write by the book, but I'm not going by the book. I'm going by just short things that you can just understand. If you understand, you can make it by your own way. Okay, you can write it by your own way. And also the science doesn't say that every time you have to go through the similar, not just the same as the written in book. It is not said. So I think the understanding is the main thing, and I have made it ready for just to understand, not just to write in the same as a book. Okay, so if the outermost energy level Oh, okay. One thing, the energy level. Those for the instead of energy level, you can use shells or you can use orbit. Okay. If the outermost energy level or shell or orbit, whatever you're gonna write, it doesn't matter. Those are the same thing. Has only the s orbital. Has only s orbital. Think about it, the s orbital. But we know there are 4 orbitals, s, p, d, f. So if the outermost energy level or stellar orbit has only s orbital, then total number of electron of s orbital in last shell or orbit, okay, or you can say the outermost energy level. So the total number of electron of s orbital in last shell or orbit or outermost energy level will be the group number, will be the group number of a given element. Okay, so but think about that. If just S, think about that. If the outer shell or outer orbit or outermost energy level has only s orbital, like I have told you one example earlier, that potassium, right? Potassium has 19 electrons, and if we divide it by break it through by the orbital structure, so actually orbital structure, then we can say it has 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Think about that. First shell, second shell, third shell, or to what I can say, those are first energy level, second energy level, third energy level, and fourth energy level. So the outermost energy level, this one, and this one has only the s orbital, and the number of electrons in the s orbital is 1. So the outermost energy level has the s orbital, and the s orbital has only 1 electrons. So this 1 will be the group number of potassium, right? And also we already knew that potassium has 4 shells or 4 energy levels. So the period of potassium will be 4, right? The number of the shells or orbit or energy level, this is the number of period in the periodic table of any element, and also the outermost or the last shell or last orbit, the number of electrons, this is the number of his group. So the fourth shell, the outermost, and the last shell or the last orbit has s orbital, and this s orbital has only 1 single electrons. So if it has 1 electrons, then the group number will be 1. If it has 2 electrons, the group number will be 2. Like after calcium, what you can go through? Potassium, we can go through calcium, right? So calcium is 20. So everything will be same, like first shell, second shell, third shell, and the fourth shell has, think about this, fourth shell is 2 electrons. So the group of calcium will be 2, because it has the outermost part has s orbitals, and also this s orbital has 2 electrons. The number of electrons is 2 of the most outer energy level. So this will be the group number of this element. So this is a bit easy, I think. So let's just go through the, not the typical way, just a complex way beyond this one. So we know the element, the outermost energy level of any element has only s orbital. What if the outermost energy level has 2 orbitals, like s or p? So the second one, at the outermost energy level or last shell or last orbit, whatever it is, if the outermost energy level or last shell or last orbit. I am using the shell and orbit for actually understanding purpose actually. So the most modern ways are they are called energy levels. So last shell, and if the outermost energy level or last shell or last orbit has both s and p orbital. then what will happen? Then the total number of electron Okay, so now I am making two examples. Think about that. If the outermost energy level last shell or last orbit has both s and p orbital, think about that. Just both s and p orbital. We had the rules of just consisting just s orbital. So these rules have consisting both s and p orbital. Then the total number of electron in s and p orbital of last shell or orbit or outermost energy level added with 10. Think about it. Added with 10. You cannot just put the total number of electrons of s and p. You have to add 10 with this, such as an example like aluminium. Aluminium has 13 electrons. If you can just break it through by the orbitals, then we can find 1s2, 2s2, 2p6 and also 3s2, 3p1. So think about that. First shell, second shell or third shell, or first energy level, second energy level and the third energy level, and this third one is the outermost energy level. So the outermost energy level had one s orbital and one p orbital. So one s orbital and p orbital, think about that. The total number of electron in s orbital and p orbitals are 2 plus 1 equals 3. So the group is actually 3, right? But we have 13, right? You cannot just say that. You have to add 10 with it. Then you can get the atomic number of it is. Also, we can find another examples. Like also think about chlorine 17. Just break through by the orbitals 1s2, 2s2, 2p6, 3s2, 3p 5, right? So first energy level, second energy level and third energy level. So third energy level has think about that. A s orbital and a p orbital. The total number of s and p equal to 2 plus 5 equals 7. So is the group number of chlorine is 7? Just see the periodic table and let me know. I think you have already seen this and you know that the group number of chlorine is 17. How? Because the total number of s and p have to added with 10 to get the group number. And I have also told you earlier in this video, that a bit complex way. So 2 plus 5 equals 7, and it is not the real group number. So if the outermost energy level has both s and p orbital, then we have to add 10 with the total number of electrons in s and p orbital to get the group numbers, right? So to get the group numbers of chlorine, like 17, we need to add the number of outermost energy levels s orbitals electrons and the p orbitals electrons. We can get the number of 7, and we have to add 10 with it, then we got 17, and this is the group number of chlorine. So I think one examples is enough. What do you think? Let me know by the comments. Also subscribe the channel, like our videos, share with your friends. Okay, anything you can, it will be appreciated, and I'm trying to make more and more videos to help you actually. So let's get through it. And the third one, actually not just the third one, actually it will be the last one. Okay, so this class won't be boring, I think. So I'm actually taking class, trying to take it a smaller way, in a smaller quantity, in a less minutes than before. So the third is, so think about that. The first one we have discussed about S, the second one we have discussed about SP. Now in a theoretically or continuously we have to get through SPD, right? So the third one is, if the outermost energy level, or you can say last shell or last orbit, has s, p and d orbitals. Now they have all three orbitals, right? Then so now I am clearing it to you that if any most energy outermost energy level has or last shell or last orbit has a SPD, then P won't be counted. Think about that. Then P won't be counted. Just you have to leave P. You have to count just S and D. Okay, you have to count just S and D, not P. So if the outermost energy level of last shell or last orbit, I'm writing twice of this. If you can find, or if you can understand, or if you can choose one of those three words, last orbit has s, p and d orbitals, then the total number of s and d orbitals, I already told you that you have to leave p. You have to leave p. So if the outermost energy level, last shell, last orbit has s, p and d orbitals, then the total number of electrons in s and d orbital of last shell or orbit or outermost energy level will be the group number of any element in periodic table. So I am giving time, some few seconds actually, not the minutes. I think not a lot to write. Just you can understand, then you can write in your own way. It is not actually statement or definition by some scientists that they have to write the same as the book or as the written things on all stuffs. So try to understand and make it a note in your own ways. It doesn't matter. The matter is how we understand it and also how we can express it. So if the outermost energy level last shell on last orbit has this p and d orbital, then just leave out the p orbital and add the total number of electrons of s and d orbital of outermost energy level, not the other energy level. Think about that. Not the other energy levels, the outermost energy level, or in a short ways you can say the last shell or last orbit. Like I have told you think about chromium. Okay, think about chromium. So what is the atomic number of chromium? 24, right? So the atomic number from chromium is 24. So just trying to break through its electron configuration by orbitals. So Cr24, 1s2, 2s2, 2p6, 3s2, 3p6. What? 3d? I am not writing 3d actually. I will write 4s2 first, then I will write 3d. So 2 2s are 4, 4 and 6 10, 10 and 2 12, 12 and 6 18, 18 and 2 20. So the 3d will have 4 electrons. So the outermost, think about it. So outermost part has s, p and d. So what can I say? So I have to leave the p orbitals. Already I have told you that I have to leave p and I have to leave p and add the total number of electrons in s and d. So think about that. The outer shell, this shell has s and this shell has p and d, but we have already s and outer orbital, so this s won't be counted, right? This s won't be counted. So this s won't be counted. That means we have p, d and s. But by the rules, we will not count p. So we have to count d and s. So the number in d is 4 and the number is in s is 2. So the group number will 4 plus 2 equals 6. So the group number of chromium is 6. So this is the rules I have talked about to the class. So I think you have understood. Now I am going to a typical or normal element, just one element with the every rules I have discussed in the class. So let's go through the examples. We can get better result if we solve examples like this. Okay, then go to ferrum. What do you know by ferrum? It is iron, right? It is 26. So just breaking through it by the orbital system. 1s2, 2s2, 2p6, 3s2, 3p6. I am not writing 3d. I have to write 4s2. Then what we have? 2, 2, 6, 10, right? 10, 18, 20. So we have 6 electrons left. So then we can go to 3d6. So think about that. First energy level, second energy level, third energy level and fourth energy level. So the highest number of energy level is 4. So we can say the period of Fe equals 4, because the highest number of energy level will be the period of an element in periodic table. So how can we find the groups? To find groups, we need the orbitals numbers, right? So it has, in the last shell it has p, s, p, d and s. So I've told you earlier examples in a normal way that it has also s. So this s won't be counted. We cannot count it. So by rules we cannot count p, because if we have s, p, d, then we have to leave p and count only the number of electrons in d and s. So the number of electrons in d and s add it. What will be the result? 6 plus 2 equals 8. So the groups of Fe will be 8. So these ones continues or by the third, okay, the third rules, and we can go through the another one, like think about that. What? Yes, go through the sulfur. Sulfur, yes, right? 16. 1s2, 2s2, 2p6, 3s2, 3p, what? 2, 2, 4, right? 4 and 6, 10, 10 and 2, 12. So this is 4. So 1s2, 2s2, first energy level, second energy level, third energy level. So the third energy level has 2 and 4. So the addition of 2 and 4 equals 6, but by the rules we have to add 10 with it to find the groups. 16. So we know the group of, so we can call it the group of S sulfur is 16. What will be the period? You can answer for me, right? I think I have already got it, that energy level is first one, second one and third one. So the highest number of energy level is 3. So the period of sulfur will be 3. So I think that is all for today, and you can find the position of any elements in the periodic table by this class. Also, if you have any misunderstood or any misleading things in the class, let me know by the comment. Also, like this video and share it with your friends that may have they have been helped by you by this video. So okay, I think that is all for today. Good day, stay safe.